Okay. Hello, everybody. Welcome to the course on computer graphics at KAUST. Those who have already made it, I hope you can hear me and see me. For those who are still coming, I hope you will manage. But anyways, I will be recording this first lecture as we have it now in real time on Zoom, and then I will provide also this lecture recorded on the website of the Blackboard dedicated to the computer graphics course. So without further ado, let me share my screen where I will tell you first through the first slide deck about the organization of this lecture, and then there will be space for you to ask any questions so that we can clarify how we're gonna proceed along the way in this course. So let's start with the lecture first. And I hope, no, it's just a second slideshow. And it should start here, but I'm not allowed to do it now for some reason. So monitor, primary monitor. Yeah. Okay, hopefully you can see my screen now. And let's start with some basic descriptions of this course, because this course is offered within the computer science program, and it requires the computer science knowledge in order to be, and also mathematics, basic mathematics knowledge, in order to be successful in this course. So in this course, we will learn about fundamental computer graphics algorithms and methodologies on the very, I would say, low level, so that whenever you will be using computer graphics later on in either higher level APIs or through game engines or through any other sort of higher level interface, you will be aware of what these individual effects which you are experiencing or using are, how they are made. So you will be able to implement any of these things. You will have a good understanding of what should be done in order to generate such image or perform such a modeling task. So it will also develop you on the left part a skill of programming essential for graphics techniques. But we will not learn the graphics APIs which are using the GPU. This you can learn either by own studies or as a part of a software or computer science project, or as a part of other courses, like, for example, the GPU techniques offered by my colleague Markus Hartiger. So we will be programming the algorithms from scratch and not using any API for sort of taking a shortcut. We will also strengthen the understanding of mathematics, physics, and signal processing aspects which are sort of leaking into computer graphics are important there. So this will be another aim of this of the learning process of this course. I feel obligated to tell you what I think is this course not about, because it might create some confusion. Computer graphics course as a CS course, computer science course, will not be about visual design, arts, or visual communication. We will not be using Maya or 3D Studio Max or Adobe products in order to create some artwork or a model or anything like that. This is not the aim of this course. Also, we will not be using already implemented graphics software for making games or movies. We will not be using any graphics APIs, Vulkan, OpenGL, DirectX methods, nothing like that will be used in this course deliberately, so that you can learn all these things which are implemented in these APIs, how they work from the low level. We will be also not using game engines such as Unreal or Unity or other sort of graphics engines to get us up the speed and take a shortcut in getting appealing visual result done instead of us doing it completely from scratch ourselves. So just that is very important now, that it is a key for you to understand that we will not be using graphics and graphics software or graphics techniques, but we will be programming them or learning how they work conceptually from the lectures. I hope this is clear, and if you have any questions regarding that, you can ask me after I am done with this slide deck. how will this lecture be organized? Of course, as any other lectures at KAUST, at least in the computer science program, we will start with online lectures. And I actually anticipate that we will be having the online lectures until the end of the semester. So there will be no physical lectures during this course. I'm not such an optimist that would think that will happen. I also have decided to give you only one lecture, which is sort of given in real time at the time when the lecture is supposed to be scheduled, meaning today. And all other lectures will be pre-recorded so that you can look at them and watch them, view them at the time which is convenient for you. Maybe not all of you are currently at KAUST. Some of you might be abroad and staying in a different time zone, so this will be more convenient for you. However, we will be using the time slots given by to us, so Mondays and Thursdays 3 to 4:30 or 4:15 for Q&A sessions. And these Q&A sessions will be optional, meaning that if you have a question, then you should either until Sunday midnight or Wednesday midnight, depending on to which Q&A we are referring to, you should send your question to me or to the TAs so that this question can be then taken up on the Q&A session. So by midnight the day before, you should send your questions, and that will determine whether the Q&A session will be happening or not. Now, for all the programming assignments, there will be 4 programming assignments, and we will come to that right away. But for the programming assignments, there will be Q&A session on Mondays from the 3 o'clock to 4:15, 4:30 Kingdom time. And for Q&A for the lectures will be on Thursdays, 3 o'clock to 4:30. As I said, this is optional depending on whether there will be any questions from your side. The evaluation of the lecture content will be evaluated, your knowledge will be evaluated by a written exam at the end of semester as a final exam. So there will be no midterm exam because you will be busy with the programming assignments anyways. I hope that by the time of when the final will be scheduled, which will be in early December, we will already be able to meet physically, and I anticipate that this exam will be maybe taking place simultaneously in 2 lecture rooms at KAUST, and we will have enough of space between each other to secure safety and have the written exam sort of a physical one. Should that not be the case, we should prepare ourselves for giving the exam remotely. And of course, while I, in principle, trust in everybody who is participating on the course that they are motivated to show their knowledge in an honest way, I would still require that we have on such a remote exam as a kind of video surveillance, just by running a Zoom on your, let's say, cell phone, which is connected to a charger so the battery doesn't run out. And then I can see whether you are sort of working on your assignment or you are looking somewhere else and possibly seeking for information from some other sources, which will of course not be happening, but you will certainly understand that a certain surveillance during a lecture exam is necessary. The lecture exam will only constitute 30% of the final grade. The most of the work and most of the contribution to your final grade will be given by the lab. So let me come to the lab, but before that, I would like to point you, when I was a student, I always appreciated if I have a good textbook as a basis for the course. So I'm following this, my own preference, so to say, and I decided to use the Fundamentals of Computer Graphics 4th edition as the book for this course. I don't know if you can see me while sharing the screen, but the book I have here in the physical, and you might be now in a panic that you do not have this book, but don't worry, because we have this book in the library. However, the library is for some reason now not really offering this book, and when you search for it, just a second, what I wanted to show you is this should be perhaps, no, I want to show you a browser that what you need to do in order to access this book is to go to O'Reilly. This is the URL, which you have also here. So you can just, you will get these slides as a PDF. In fact, you have these slides as a PDF already in the Blackboard interface. Let me show that to you just very quickly. So if I'm going to the courses, I have here several things, but you should have the course here, and then I go and click to the course content. Then you will see there are two different folders here. One is slides, and you see here organizational slide. This is the one which I'm now currently using. Introduction to computer graphics, other lectures, which are until the chapter 4 now already here in form of a PDF directly from the slides. Or if I look into the videos, I can see that there are already 3 pre-recorded videos, including the ray tracing. And that has a very good reason, which I will come to that in a second. So, but let's just have a look at, so in these courses, you will find these slides. And in these slides, you will find, you will find the link to the O'Reilly website where this Fundamentals of Computer Graphics 4th edition is available. O'Reilly is, of course, having a paywall. So, but you are not supposed to pay for that, because you should use the KAUST email address as your login information, and then you should register at O'Reilly, and then you will have the access to this book for free. So then in the browser, you can comfortably read it, like, for example, the chapter 4 here, and you can see that things work reasonably well. What previously didn't work that well was rendering of equations in Chrome, for example, and it worked only in Firefox quite well. But now this has changed, and I think we should not experience any complications of reading math equations in any of the current popular browsers. Okay, so this is where you will find the book. And I recommend you to, before you watch any video of the lecture, which I have pre-recorded for you, you read the respective chapter. And there, where you are not so sure of the interpretation, perhaps my lecture will help you understand it a little bit better. But please understand that the lecture in itself, as given by me, is perhaps not sufficient for understanding the material, and you will need to go back to the book and read the respective chapter about it. Okay. So now, as I said, the chapters 2, 3, 4 are already pre-recorded. I will be working on the chapter 5 tomorrow, and I hope by the end of this week I will proceed with some more pre-recordings. Essentially, I want to get us with the pre-recordings well ahead of time. So if I look at the roster of our syllabus, there we should basically this week only have the introduction to computer graphics and raster images. And the ray tracing should come relatively soon next week. But I want to give you these videos and the text to read already this week, because I really want you to work on your first assignment for the lab right away. And for that, you will need to read up to the chapter on ray tracing so that you are capable of implementing the assignment 1. Okay, so now I think we can switch to the lab organization. So here we will be implementing the essential graphics algorithms. Oh, there is perhaps a question, or there is something in the chat. Aha, very good question. What programming language are we using? You can choose. So you can use any programming language which you prefer, and you can also use a framework for implementation which you prefer. So for example, you can use something which we like which is called open frameworks, or you can use Qt, you can use Cinder, or you can use the SDL2 as a general framework. But in none of these tools, you should exploit the existence of graphics capabilities or graphics pre-coded libraries or any bindings to the graphics APIs. That should be implemented by yourself. So, for example, for the assignment number 1, you can use one of these frameworks or any other framework which you prefer, just to generate a window into which you will be then drawing the individual pixels during the ray tracing. And so everything to generate the window, you can use shortcuts, so to say, and help from some frameworks, software frameworks. But the graphic algorithm itself, you have to code from scratch. Therefore, these assignments will take time. None of this assignment is an assignment which you will be capable of completing within 1 night of coding. Guaranteed not. however good you are in coding, each assignment takes approximately 1 week of coding, plus minus, depending on how efficient you are in coding, and so on. So, and how focused you are or could be. So start very early. My wish is that by the next week, you will be already able to be either discussing the open questions on the Q&A session, and by the end of next week, you will already have your assignment number 1 already completed. The deadline is later, but I want you to start very early, because otherwise you will run into a time issue. And now we can still celebrate the time when there is not so much to do for maybe other courses, because the courses are slowly starting. So use the time now wisely so that you can get your assignments in computer graphics done as quickly as possible. Excuse me. After the assignments are done, there will be 4 assignments. We will have one presentation, which will again be organized in the times of Mondays or Thursday on our usual lecture times. So this is already, I have already scheduled it in the calendar. I will update you on when this is going to happen, but essentially it will happen the one day after your deadline of the assignment. The grading is the following. You will be having the 70% of the grade is made out of the lab contribution, lab performance of yourself. And within each assignment, you will have 80% of obligatory task, which you need to complete. But even if you complete that, 100% what is written there, you have completed that task only to 80%, because 20% is given you to make something creative, something which is not defined in the task, but you can do something more. For example, in the ray tracer, you will be given that you should perform ray tracing on various objects. So maybe you will, in the obligatory part, you will be having just 2 different types of objects, but you will create an intersection test with another type of object, let's say a cone or a cylinder or something like that. This will go on the top so that you can score 100 points for each of your assignments. Okay. So for the lab, the deadlines are at the end of September, 27th of September. There will be the deadline for the ray tracing on the 28th of September. We will have the presentations from each of you, which will be something like a 8 minutes presentation of what your ray tracer can do. And after such a presentation, in the next days, you will do a code review with the TA to see whether you completely can describe your code and whether you can show how it is being executed and what is done where, so that you both understand your own code and also understand the technique which you have implemented. The next assignment will be in the mid of October, and we'll be building on the first assignment. So you will turn a simple ray tracing, which will not be interactive, into an interactive one, so that you can change the camera or move the objects. The third assignment will be to create your own rasterizer. So basically, the OpenGL or other graphics APIs are rasterizers, hardware-based rasterizers, and you will be implementing that by yourself. So you will be rasterizing the scene, and that type of rendering is due by the first week of November. And by the end of November, we will come back to the ray tracing, and you will be programming some advanced ray tracing techniques. Please keep in mind, we will train how to be timely in this course. This will be a natural side effect of this course. There will be no deadline extension, 0. There will be no, if there is no hand in from you on one of these dates, there will be no points, 0. So therefore, I'm urging you to start coding right away, so that you will not lose a point because of being late. I have already mentioned this, 80% of the work, my wish is, or your measure of success, whether you can keep up with the deadline, should be that the 80% of work, the obligatory part of the work, which is defined in the assignment explicitly, should be completely done 1 week before the, prior to the deadline. Okay, now I also feel obliged to tell you at this point, what is the grading scheme? So the grading scheme you can see here is as follows. This is the 4-point grading scheme, and the A for that you will get only if you get between 100 and 93%. And this is a combination of 30% from your lecture exam and 70% of your lab. Okay, so I hope you will all be able to celebrate the best grades, but keep in mind that this is the scale and we are not going to change the scale. All right. Now, this is everything from my side according to the organization of this lecture. I would now welcome you to tell me or ask me what are the questions you have to how we're gonna run it. I see here Alejandro is already asking me one question, and maybe this is a good way to ask that you are just posting it into the group chat. Will the final exam include coding or just theory? Good question. You will actually get 2 exams for training so that you know what to expect on the exam. You should not do the coding. So if you will do some syntax error on coding on paper, no, this will not be evaluated, but what will be evaluated whether you can perform a particular algorithm. So you will be asked, for example, to calculate a particular point along a curve where what is the position of that point given some parameter when we have available a parametric definition of the curve. So you will need to do the math yourself. Also, it is a closed book exam. The training exams will occur soon. I think we can provide them relatively quickly, and they will be pasted in the content of this of the course on the blackboard. Yes, I see a raised hand.
So I just wanted to clarify that the exams aren't, so they're the exams from last year, right?
Yes.
Yeah, so people are not going to retake the exam, they're just going to have the answers to the questions, or just the questions.
Yes, exactly. So
okay.
These exams will not happen at the final exam, of course. Okay. Are there any other questions? Please, thank you for the question. The order is basically given in the order how they appear in the order from top to bottom, and it's basically the individual chapters of the book which I was referring to. Please watch them as soon as possible because you need the ray tracing to be capable of to do your assignment. So these are 3 videos, reasonably long, and but I'm sure if you sit down in the evening and drink some soda, you can watch through all 3 of them within one go. I recorded them in such a way that they are a little bit speeded up so that you are not bored by my slow pace of talking about the lecture content. Good point. So I'm going to introduce the teaching assignment. Thank you, Rodan, for that. This will be Yusuf Aldolian, who is also on the call, and he was just mentioning or relating to one question before. So Yusuf will be available for discussions, clarifications of the assignment. He will be then present at the Q&A, and he will also be present at the code review, which will be given at the schedules, which will be both comfortable for you and him. In addition, there will be Onjay, who will be also helping out with this with the teaching assignment duties. So Onjay Sternad, who is also on the call, will be helping you as well. Maybe it would be a good idea if I share the email addresses of these 2 gentlemen, so that let me do it right away in this presentation, so that you have it within the organizational slide deck. I will update these slides then afterwards. Contacts, and this will be me and TA, and I will finish it just after our lecture. All right. Is there anything else we should discuss at this point? Something which is unclear? If you will experience any difficulties with seeing the book online, please let me know. Maybe we can. I definitely have a PDF of the 3rd version, which was available somewhere on internet. So in the worst case, we could use that one. But I'm optimistic that everybody who is enrolled as a CAUS student, has a CAUS email address, is able to log in into O'Reilly and be able to read this book online. Any other questions? Doesn't seem to be the case. If you would have some on the way, just go ahead and ask. But I will now start with what is our time now? I will now start with the very short introduction to computer graphics, so that you have the first sort of chapter behind you. It is an introductory chapter and will not be part of the exam, so I didn't bother to pre-record it especially, but we will just quickly go through it, which brings us then for the next lectures into the topic of computer graphics, and you can continue the lecture by watching the videos. I hope you all have access to the videos, but I don't see a reason why you shouldn't, because it's all sort of on the uploaded to the Blackboard. Okay, so the computer graphics is a study of creating, manipulating, and using visual images in a computer, as the definition says of this book. Typically, in computer graphics, we are concerned with creating virtual worlds by modeling them in various ways of maybe static or dynamic scenes, then rendering them. Rendering means out of the 3D scene, creating a sequence of images, or just one image for the example. And then another main area is computer animation. So even if we model everything and render it as a static scene, then another sort of a big component of computer graphics is how to make things move, how objects should be animated. Should it be, you know, humans in the crowds being animated? Should it be the camera animated as a movement throughout the scene? So all these temporal components are yet another big chapter, and actually would deserve a separate course on computer animation itself. We do not offer such an course at KAUST, but if you will be, we have just one lecture on computer animation within this course. But if you are interested in more details on computer animation, I can recommend you some book which discusses the fundamentals of computer animation in more detail. But the rendering will be a detailed part of this course. We will dedicate most time to that part. The related areas to modeling, rendering, and animation are other branches or of computer graphics, you could say, or related research fields or disciplines, like, for example, user interaction. Now we have a separate user interaction research, which is not necessarily bound only to graphics, but it is the interaction with user is often somehow bound to some visual communication between the user and the machine. So it is tightly related. Also, virtual reality is or augmented reality or mixed realities are tightly bound to computer graphics. We need to generate images, and we need to generate them very quickly so that the virtual reality applications get a satisfactory quality of the experience. If we are dealing with scientific or other kinds of data, we often need to display them on the screen, and that's where we are also using computer graphics techniques. Sorry. In image processing, we generally are not synthesizing a scene, we are rather processing a scene, but image processing is tightly bound to computer graphics. Often we need to process certain scene, smooth it, or otherwise filter it before we can use it and create imagery of that. 3D scanning by various technologies such as laser scanning, for example, is creating huge data which then need to be displayed in order to benefit from such a representation using computer graphics techniques. And there is a lot of computer graphics needed for computational photography. So when you take a picture these days, it is not like there is no processing happening after the sensor sort of senses the intensity of incoming light. There is a lot of processing, and you can appreciate that when you browse through all the features which the current cell phone applications of photography has. So computational photography is also a very related branch to computer graphics. The applications of computer graphics are games, for example, 3D games, where the top requirement is high performance, so that we gain interactive speeds and possibly a great visual experience. on the top of the gaming experience itself. So the computer graphics is a big challenge to deliver very high quality imagery within interactive frame rates. In creating cartoon animations, we are often using 3D computer graphics as well. So there will be 3D objects, but then we are using a 2D-like visual appearance so that these cartoons then look like hand-drawn cartoon animations. Visual effects are all benefiting from computer graphics and the film industry as well, such as the last year featured movie from Disney, where you have the entire animal world sort of represented by computer graphics. These days, if you are able to shop from IKEA because of the restrictions, you get some catalog, and these days this catalog is fully just computer graphics. Nothing is a photograph anymore there. So while this probably doesn't deteriorate the quality of the furniture products, don't believe to those pictures that they are sort of physically correct, because they have been generated by computer graphics techniques. We can also use computer graphics in simulations. Just recently, the Microsoft Flight Simulator has been released, and some people already tried and spent several hours on the simulation and to enjoy the accuracy of the flight experience and the piloting experience. Last but not least, the visualization is strongly benefiting from computer graphics. Here, for example, you can see an image from ultrasound imaging of a fetus, not yet born child, so to say, which has been acquired by a 3D ultrasound. And previously, 3D ultrasound was just a mess. You couldn't see anything there. And if you could recognize a hand or a face, you would be already lucky. These days, the quality of graphics, interactive graphics, is so that it is indistinguishable from a camera imagery from sort of from fetal filming. Another aspect which we are dealing with in our group would be molecular graphics or molecular visualization, where we have such huge, tremendous scenes which are forming complex structures on the molecular level. So here, the computer graphics again needs to be very performant in order to and efficient in order to maintain and be able to display these very complex scenes of life forms on the molecular level. And the first chapter of this book, which I flew through very quickly, contains additional interesting information on how are numbers represented on the computer these days and what are the possible numerical issues. I encourage you to look into that. And maybe the most valuable part of this chapter in the book is some hints on how you should debug the graphics programs. So some recommendations on how you should design your program, or how, in case you are experiencing some difficulty and undesired behavior of your program, how to deal with it. What are the basic strategies of debugging graphics programs? So please check that out in the book for more details. So that will be all for the introductory chapter. As I told you, it's rather short. The other chapters will be longer and more in-depth. I thank you for your attention, and I'm still ready for answering more of your questions, should you have any. All right. If that's not the case, then I will be posting the updated version of the organizational slides online, and in the content of the Blackboard website of the course, you will see always more and more updated lectures. And once I update it, I will also send you a short email so that you know that there is new lectures to be watched.
Excuse me, Professor, are we going to have a more detailed description for the first assignment? Because
yes. Very good question. That is already available. So if you look at the
yeah, I checked this assignment actually a couple of days ago, and are we going to have some additional requirements or maybe more details?
So this is, can you see my screen?
Yes, I do. Oh,
yeah.
Oh,
so
the
assignment 1.
Yeah, archive was missing the last time I checked, so I suppose it contains some of the details.
What was missing? The archive?
Yes,
okay.
This zip file was missing the last time I checked.
So this is the description, which is, in my opinion, rather detailed. So you should know what to do, and if not, then just ask some questions should you have any. And here is the template of the Open Frameworks project. So if you decide that you would like to use Open Frameworks just to be able to render a canvas in which you can draw your pixels after the ray tracing, then you can use the Open Frameworks, but you do not have to. You can use really any framework you want. The only condition is, and any language you want, the only condition is you cannot take any shortcut and use graphics code which has been already programmed by somebody else.
Yeah, I understand. Okay, thank you.
You're welcome. All right. So in case this was more or less clear, then let's conclude this lecture, and I will see you at the Q&A session, hopefully this week on Thursday. Please post me your questions related to the lecture content, so that one day before on Wednesday, so that I can prepare my best to explain you those unclear parts.
Just one last question, probably. Do we just email you directly, or we put it somewhere in a discussion channel for the questions if we have?
Another good question. So I do not really see here, and there is a discussion board here, right? But I haven't experienced this this interface of the discussion board. So we can create a forum here. So I guess this could be a way how we can interact. I will look into that, and I will let you know. I will let you know today or tomorrow, so that you can then use the appropriate channel. But if you will have a question with you can always send it to us by email. Use it.
Yeah.
Your hand was up.
Oh, it was up from last time.
Ah, sorry. Okay.
What? Okay.
All right. So I will let you know whether this discussion board is something which we should use, or we just use emails. For now, emails, but this is likely to change. Okay?
Sure, thanks.
You're welcome. All right. So.
And I have one last question, maybe. What, in your opinion, are video lectures enough to be able to complete the homework assignments? Or we also should refer to the textbook you mentioned?
So I'm giving you the textbook, and all the course is around the textbook, so that you can always come back to the textbook and read the details at your own pace. You know, sometimes you just need to look at some formula and derive that formula yourself, so that you fully understand that. And for that, the book is irreplaceable. But if you find that you have understood everything of what I described you on the lecture itself, then probably, and you find it enough of information so that you can complete the assignment, then this is likely enough for you to do the lab sufficiently, and also to have enough of knowledge for the exam.
Okay, thanks.
You're welcome. Okay, so if that is all, then let's stop here. And I thank you for your attention and wish you a lot of fun in computer graphics course. Bye-bye.
Thank you.
Thanks.
Bye. Thank you.
Thanks.